Welcome to section 5.2, video 1 of 2 videos. In section 5.2, we're going to be talking about the trig functions of real numbers. So section 5.2, trig functions of real numbers. So let me give you a definition of what we're talking about here. So let t be any real number and let the point P, which has coordinates x, y, be the terminal point, on the unit circle. So on the unit circle determined by t. This is like video 2 from section 5.1, figuring out the terminal point, and we're taking those coordinates of that value p of x and y. So if we have that terminal point, if we have those values for x and y, then we have the following. We define sine of t. So these are going to be our trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent. So sine of t is just whatever value of y that we had from that terminal point. Cosine of t is the x value. So if you're going to remember anything from this section, this is it. We are going to use this a lot throughout the semester. Cosine refers to our x value, sine refers to the y value. Once we have that, we can kind of figure out the other ones. Tangent of t is just y over x. Now obviously, because we have an x in the denominator, x can't be 0. So there will be some values for tangent that are undefined because we know we can't have 0 in the denominator. Then we have the last 3. So the first of these is cosecant of t. So we have cosine, and the natural assumption is to say, oh, that relates to cosecant. I'm going to tell you now, no, it doesn't. The other one we have is secant of t. Cosecant of t is 1 over y, so that's related to our value for sine. Secant of t is 1 over x, so that's related to cosine. So what you can see is that secant starts with s, it's not related to sine. And cosecant starts with c, it's not related to cosine. So again, if you're going to remember something from this section, remember that secant goes with cosine. Cosecant goes with sine. Don't try to match them up because they sound similar, have the same letters. If anything, think the opposite. And then lastly, cotangent of t is x over y. And again, in this case, y cannot be 0 because it's in the denominator. So go ahead, pause, get these copied down if you need to, and then we'll go into an example. All right, so the example we're going to see, and I'll tell you this is going to be one of the first kind of problems you're going to have on exam 1. and it'll say the following. Find the 6 trig functions for, the first example we'll look at is t is equal to pi over 3. So we know that we need the x values and the y values to figure out these trig functions. So the first thing we have to do is figure out what are my x values and y values for pi over 3. So if you haven't memorized the unit circle yet, if you haven't come up with your own trick, let's remember our Pinterest trick. Pi over 3 is what? It's here. So that means I know I have 1 and 3 in the numerator, and they always get square root, and then the denominator is always 2. So for pi over 3, I know my coordinates are 1/2 and square root of 3 over 2. That means that this guy is my x value, that one is my y value. So sine of t is just whatever my value for y is, square root of 3 over 2. Cosine of t, that's just whatever my value of x is, which is 1/2. Tangent of t. So tangent of t is y over x. So square root of 3 over 2 all over 1/2. So this is our fraction math. If we're going to do keep, change, flip, we have square root of 3 over 2 times 2 over 1. We keep the first one, we change the sign to multiplication, and flip the 1/2 to be 2 over 1. The 2's cancel, which means this is square root of 3. Now, on that unit circle handout that I gave you the first day of class, you already know these values, you have those on there, 1/2 and square root of 3 over 2. What I would do, because it's going to save you a lot of time going forward in the future, is outside of this, I would just write square root of 3. That way you know that's the value for tangent. So when you're doing problems throughout the semester, if you need tangent of pi over 3, you know it's square root of 3. You don't have to go through and try to calculate it. All right, so sine. What goes with sine? Well, cosecant goes with sine. And it's 1 over y, which is 1 over square root of 3 over 2, which is the same as if I just flip this guy. So 2 over square root of 3. Now, we don't like radicals in the denominator, so we want to rationalize it. So I'm going to multiply the top and bottom by square root of 3. So when I do that, the top becomes 2 square root of 3, and the bottom is square root of 3 times square root of 3, which is just 3. So cosecant of t, the value if I was doing a homework problem would be 2 times the square root of 3 over 3. All right, now secant of t. Secant is just flipping over whatever my value for cosine is. It's 1 over x. So 1 over 1/2, which is just 2. So secant of t is 2. And lastly, cotangent of t is x over y, so 1/2 over square root of 3 over 2, which is 1/2 times 2 over square root of 3. So the 2's cancel, I get 1 over square root of 3, and again, I don't want radicals in the denominator, so I multiply the top and bottom by square root of 3 over 3, and that just gives me square root of 3 over 3 is the value for cotangent. So those are my 6 values, 6 trig functions for pi over 3. All right, let's do another example. So as you're probably familiar with now on these examples, I'll give you guys the example. Go ahead, hit pause, try to work it out. If you get stuck, if you get done and you want to check your answers, hit play again, come back and see if you have the answers right. So we want the 6 trig functions for t is equal to pi over 2. So go ahead and try that. Come on back once you're done, or if you get stuck, and I'll help you work it out. Okay, so the first thing we need is our x and y values for pi over 2. Pi over 2 is straight up the x-axis, so that is 0 and 1. So sine of t is whatever my value, so this is my x, this is my y. So it's just 1. Cosine of t is just whatever my value for x is, 0. Tangent of t is y, which is 1, over x, which is 0. Big trouble. Can't have a 0 in the denominator. If we have a 0 in the denominator, this means what? This means this one is undefined. I see a lot of students, they always have trouble. Is it 0? Is it undefined? They're not sure. They've never been taught a trick, or they've never really figured it out. So I'll show you this trick. Maybe that'll help. If 0 is in the denominator, it is what? It is under the 1. 0, or whatever number is in the numerator. It's under that number. So UND should tell you that it is UND, undefined. If 0 is in the denominator, that tells us that it's undefined. 0 is under UND, so undefined. Hopefully, if it's always been an issue for you, maybe that little trick will help you. The other 3, sine is related to cosecant. And that's just 1 over y. So 1 over 1, which is 1. Secant of t is 1 over x, 1 over 0. There's that 0 in the denominator again. So it is also undefined. And then cotangent of t is x, 0 over y, which is 1. 0 over 1 is fine. It's just we can't have a 0 in the denominator. If it's in the numerator, that's fine. So 0 over 1 is equal to 0. So there's your answer for the 6 trig functions when our terminal point is pi over 2. All right. So trig functions have even and odd properties. If you recall back to 126, if you came from the 126 class previously, when we talk about even or odd properties of a function, because that's what these are, they're trig functions. So when we talk about even or odd, we're talking about, for example, if we have x squared and we want to know, is this an even or odd function, what do we do? Well, f, if we plug in the negative value, gives us just the same value back. So if I have x squared, if I plug in f of negative x, that's negative x squared, which is just positive x squared. I get the same thing back, so that's an even function. Hopefully that knocks a few cobwebs out or refreshes your memory. Odd is when you get the negative value back. Trig functions have these properties. So even and odd properties of trig functions. So which ones have the odd function? Well, it's sine. What goes with sine? Cosecant. Tangent. And what goes with tangent? Cotangent. So what this means is if I have sine of some negative value t, I can rewrite this as just negative sine of positive t. Similarly, cosecant of negative t is the same as negative cosecant of t. Tangent of negative t is the same as negative tangent of t. And cotangent of negative t is the same as negative cotangent of t. Those are the odd. So if these four are the odd, what are the even? Well, it has to be cosine. And what's related to cosine? Secant. So what that means is that if I have some function cosine of a negative value t, I can just rewrite this as cosine of t. It means the same thing. I can get rid of the negative sign. Same for secant. Secant of negative t is just the same as secant of t. We're on section 5.2. I've already given you guys a ton of information, a lot of which you're thinking, okay, I got to do all this memorization. I'm going to try to give you these hints and tips and tricks along the way so that you don't have to. You don't want to have to try to memorize all 6 of these. Which one are even, which one are odd, etc., etc. My suggestion to you is this. Just remember that cosine is an even function. Because if you know that cosine is, what goes with cosine? Secant. So you know that one is. If those are the only even ones, then everything else has to be odd. So you don't have to memorize these 4 are odd, these 2 are even, and which 2 are even. Just remember cosine. If you just remember cosine is even, then it means that secant also is, because they're related to each other, and then everything else is odd. So let's look at a quick example of this property. Let's say I want to find, the first one is sine of negative pi over 6. I have this negative inside. I need to use my even odd properties to get rid of it because I don't know this minus pi over 6. So what I can do is move it out. This is the same as negative sine of pi over 6. So now pi over 6 is what? If I don't worry about this negative right now, my pi over 6 has the coordinate measures of square root of 3 over 2 and 1/2. Sine is the y value of that, which means that this part right here is equal to 1/2. But don't forget this negative out in front. So sine of negative pi over 6 is minus 1/2. What if I have cosine of negative pi over 4? Well, the negative sign's inside, but it's an even function, which means this is the same thing as just cosine of pi over 4. We know pi over 4 has coordinates square root of 2 over 2, square root of 2 over 2. Cosine refers to the x value. So this whole thing is just square root of 2 over 2. So a couple quick examples for you. What does it mean even, odd? How do we apply it? And then lastly, for video 1 of section 5.2 is our fundamental identities. And specifically, the first one we're going to look at is the reciprocal identities. So cosecant of t, which we kind of saw when I was introducing the x's and y's and so forth, is just the same as 1 over sine of t. Secant of t is what? It's 1 over cosine of t. cotangent of t is 1 over tangent of t. So if I know the value for tangent, I know cotangent. I can just put 1 over that value. That's what it means by reciprocal identities. The last two, tangent of t, well, tangent of t was what? It was y over x. Well, what is y? Y is sine of t. What is x? Cosine of t. So that means if I'm given sine of t, if I'm given cosine of t, then I know tangent of t is just sine over cosine. And lastly, cotangent of t, because cotangent is just 1 over tangent, I can flip these two. So cotangent is just cosine of t over sine of t. So there you have it. That's video 1 for section 5.2. Video 2 of 5.2 will go into one of the more important identities, which is going to be our Pythagorean identities. So we'll see you in that video.